So moving on to questions 7 and 8, where both of them have to do with solving right triangles. So the idea of solving right triangles, you want to know all three sides and the two angles that aren't the right angles. We already know this right angle is 90 degrees, so we don't have to solve for that. Alright, so there's three methods we're going to use to solve a right triangle. Pythagorean Theorem, which says if I take the two short sides and square those, then add them together, then I get the same as if I take the hypotenuse and square it. Alright, 2 I just wrote 180 degrees, that's just because the three angles inside of a right triangle sum up to 180 degrees. And the last one is Sohcahtoa, which is the relationship between sine, cosine, and tangent, and then these opposite, adjacent, and hypotenuse sides. Alright, so let's try to solve this first right triangle. Well, we don't need to use the Pythagorean theorem because we already have all three sides. So the only thing we need to figure out is what these two angles are. So let's call this first one in the bottom right alpha. Alright, we'll call the one in the top left beta. Alright, so let's try to find alpha first. So the way we're going to find alpha is we're going to use any of the trig functions. So we know all three sides, we can use any of these. So let's use sine. Well, we know sine of an angle. Well, sine is the so it's going to be opposite over hypotenuse. So from this angle alpha, we need to figure out what the opposite side is. The opposite side's here. It's 3 square root of 3. Alright. And the hypotenuse is 6. Alright, so we're going to simplify this down. The 3 and the 6 so become a 1/2. So we get the square root of 3 over 2. So we know if we take sine of what angle, whatever the angle alpha is, then we have to get the square root of 3 over 2. So that means we know that alpha has to be 60 degrees. Or pi over 3 if you're talking in terms of radians. But when we're using the right triangle, we'll probably use degrees. So here, alpha, we plug that in. This has to be a 60-degree angle. Alright, so we could do the same thing and figure out beta. We could do, for example, we could do cosine. Let's do sine again. So let's do sine of beta. Alright, so sine of beta. Again, it's opposite over hypotenuse. But here, we're talking about a different angle, so now the opposite side is 3. Alright, and the hypotenuse is still, it's always going to be 6. Alright, so now we know sine of beta is just 1/2. So now we have to find an angle between 0 and 90 degrees that we plug into sine and get out 1/2. That means beta is equal to 30 degrees. Or pi over 6 if you're talking in terms of radians. Alright, so now we could have figured out each one of these from using sine, cosine, or tangent, whichever one you prefer. Or after we found alpha, we know that the sum of our angles is 180, so we could take it 180. Alright. Well, that's the sum of the three angles. We know this one's a 90-degree angle. Alright, we just figured out that alpha was 60, and say we didn't know what beta was yet. Alright, well, we'd solve for beta just by subtracting the 90 and the 60 over, and we'd get that 30 equals beta, which is exactly the same thing we got by actually using the trig functions. So now we know we solved this right triangle. We were given the three sides, but now we know that alpha is a 60-degree angle, and beta has to be a 30-degree angle. Alright. So again, use these three techniques up here. The next example, we'll use different ones, but here we already had the three sides, so we don't need to use step 1, but we can use Sohcahtoa to figure out what our missing angles are. So moving on to number 8, again we want to solve this right triangle, so we need to figure out the three angles and the three sides. So we know one angle and we know the right triangle, or the right angle here, so we're going to call this angle alpha, the one we don't know. We'll call this hypotenuse that we don't know yet C, and we'll call this other side that we don't know yet B. So if we can figure out alpha, B, and C, then we solve the right triangle because we'll have all three sides and all three angles. So the first one we can figure out alpha pretty quickly. We know that the sum of the angles in any triangle is 180 degrees. So 180 degrees is the sum of these three angles. This one's a 90-degree angle. Right. This one we don't know yet. And we know that the angle at the top is 30 degrees. Alright, so we're going to subtract the 90 and the 30 over and get that alpha has to be 60 degrees. Alright. So that's the first step, using the sum of the angles of the right triangle. So now we have the three angles, so we just need to figure out the three sides. So we're going to figure out the remaining sides from Sohcahtoa. Alright, So we know this side, alright, and let's use the angle that we already knew. So we have this side here, 30 degrees, right? And from this 30 degrees, this is the opposite side. So if we want to use the opposite side and say we want to find what C is, well, it's opposite and hypotenuse. So we're going to have to use sine, because sine is so. So we're going to have to take sine, right, of this 30-degree angle, and that's opposite over hypotenuse. But in this case, opposite, again, like I just said, is 5. The hypotenuse we don't know yet is C. So we have to solve this equation, sine of 30 degrees equals 5 over C, for C, which is the thing that we care about. Alright, so we're going to multiply C to the other side. C equals sine 30 degrees equals 5. And the last thing, of course, we divide by this sine of 30, so we have C by itself. It's 5 over sine of 30. Alright. So now we just have to figure out what sine of 30 is, and we'll get the exact value of C. Well, sine of 30 is 1/2. Alright. And dividing by 1/2 is the same thing as multiplying by 2. So this is 5 times 2, which is 10. Alright, so we used Sohcahtoa, specifically sine being opposite over hypotenuse, solve for the side we don't know, and we get that the side we did know before, the hypotenuse, is 10. Alright. And now we have a bunch of options for how we can solve for this B here. We could use Sohcahtoa again with either this 30 degree or the 60-degree angle. But the way I'm going to do it now is use the Pythagorean Theorem, which says if I take these two sides and square it, I get the hypotenuse squared. So if I square the hypotenuse, I get b squared plus 5 squared. Alright, so now I just need to solve this equation here for b in order to give me whatever this side has to be. Well, 100 squared, or 10 squared is 100. Alright, b squared plus 25. Alright, we're going to subtract the 25 over and get that 75 equals b squared. And now we want to solve for b, so we'll take the square root of both sides and get that b equals the square root of 75. Alright, well, the square root, or 75 is 25 times 3. Alright, that square root's over that whole thing. And then the 25 will come out of the square root as a 5, and I'll get 5 square root of 3. So this side b here from the Pythagorean theorem is 5 square root of 3. And now we have this right triangle solved. We know all 3 sides, and we know all 3 angles. Alright, so we used all 3 pieces. We used the sum of the angles is 180, then we used Sohcahtoa, and then we used the Pythagorean theorem in order to solve this right triangle. So the last problem on this page is number 9, and we want to solve this equation here where we have sine of 3x equals the square root of 2 over 2. So we know from in class we should be able to solve this equation. So the first trick that we're going to do is make the inside of the sine function as simple as possible. So we're just going to call it beta, like I did in class. Just call beta the inside sine, or just 3x. So now this formula here is the same as sine of beta equals the square root of 2 over 2. Alright, so now we have some nice formulas for this. The first thing, we can find sine inverse. So beta is going to be sine inverse of the square root of 2 over 2. So that'll give us one of our solutions, and then we'll get everything after that, which will be the 2 pi k. So that'll be all the different revolutions around the circle. Alright, and with sine we had these 2 different cases. If this value here was positive, we had one case, and if it was negative, we had another case. So it's positive. So what we're going to do is we take pi, which is the half angle. Alright, we're going to subtract whatever angle we found here. And then that's going to give us another angle that has sine of beta equals the square root of 2 over 2. Alright, and then we can do as many revolutions around the circle as we want. So we have to add this plus 2 pi k to make sure we get every solution to this. So real quick, if we look at a picture, we have the unit circle here, and we found one angle, sine inverse of square root of 3 over 2. So let's say it's this angle here. And that gives us the y value that we care about, the square root of 2 over 2 on the unit circle. So remember the definition of sine is just the y value of that point right there. But if we want to just have this y value, we can also look at this point across. Alright, and this point will have the same y value as well. But to find the angle that hits that point, we're going to have this angle here. Right, and the way we're going to figure out what this blue angle here is we're going to reflect this first black angle we found, which is sine inverse of the square root of 2 over 2. And we reflect it, we'll get this picture here of this blue angle. Alright, opening to the left. So this inside the black piece is sine inverse of the square root of 3 or square root of 2 over 2. Alright, which makes this piece in the blue the exact same angle, but we care about finding this piece here. So the way we find that is exactly what we did. We take this whole half angle, subtract this sine inverse of the square root of 2 over 2, which is this blue piece, and it gives us this piece left, this blue piece that we care about. Alright, so these are our two solutions for beta, and now we just need to figure out what sine inverse of the square root of 2 over 2 is. Well, that's just whatever angle we plug into sine to get the square root of 2 over 2. And the angle that does that is pi over 4. So this is pi over 4 plus 2 pi k. Alright, it's the 45-degree angle. And this one is pi minus pi over 4, which is 3 pi over 4 plus 2 pi k. Alright, so now we have these two solutions. Beta is either this set or beta is in this set of solutions. But our original goal was to solve for x, so now instead of beta, we're going to think about it again in terms of 3x. Alright, so this equals 3x, and this equals 3x as well. Alright, and our final goal is solving for x. Well, if we have 3x and we want to solve for x, we have to divide both sides by 3. So we'll just have x, and then this piece here divided by 3. Pi over 4 divided by 3 is pi over 12. And 2 pi k divided by 3 is 2/3 pi k. And the same idea for the second set, we're going to divide both sides by 3. This just goes to x, and this, the 3's cancel and we get pi over 4. Alright, and again, 2/3 pi k. Alright, so this set down here at the bottom will be all the solutions to this equation